Okay, so I inspected the soldering here. I did put a little, too little solder on a few of these points, and that's just a function of me being kind of, you know, a foot and a half away from my work. I probably should get some magnifying lenses or whatever so I can see while I'm this far away from my work, but I checked it out and it should work, and if it doesn't, well, it should be entertaining. So I managed to get a little bit of internet by restarting my modem. So I saw that Alice listed this as a 12 volt DC device, and the chip itself, the ICL 8038, should take anywhere between 10 and 30, but we're just going to go with the 12 volts today. So I'm going to hook this up, 1 and 2, and I've got my power supply here set to 12 volts. I'm going to back off all of these and then clamp down a wire as necessary. So I'm probably going to put positive negative in here. So that's positive negative. And I'm probably going to put the sine wave pin in, or the a wire in the sine hole, and then going to put a wire in the signal ground hole. So that should be in there. Yep. So signal ground would be our black. That's good. And then I'll arbitrarily take orange to do the sine wave. No idea if this is going to work, and let me know if you like this, but I have figured out a new way to display the oscilloscope, and that would be right here. So right now we've got this going on the test trace. Everything's in auto mode, single channel. I'm just going to reach up, I'm going to grab the probe, bring it down here, I'm going to turn this on, and don't know if this is working. We have 12 volts. So right now 12 volt 2 and like 10 milliamps. So I'm going to grab the signal here. I'm going to grab the ground and I'm going to hit auto and see if we're capturing anything. We are. So the signal is bouncing around a little bit, but it doesn't seem too bad. We don't know about frequency yet, so I'm just going to change the horizontal scale. There we go. So we've got 2.5 volts right here, peak to peak. Frequency is nearly 300 hertz. I'm going to move the big dial. Okay. I'm going counterclockwise very slowly. No, sorry, clockwise very slowly. And we're going up. I'm going to go more and more. Looks like I'm maxing out at about 560 hertz. 500 hertz doesn't seem like that's a lot of frequency. But that is the coarse adjustment. I will grab a screwdriver and check the fine adjustment. Okay, let's turn this. So I'm spinning clockwise. We seem to be rising in frequency. This would be a trimmer pot, so this will go up forever. 700 and I'm at the end now. Yeah, 735 hertz. And I will flip it backwards. At the other end, oh, we're down in the 500s. Starting to affect it big time now. Oh yeah, wow. Look at that, like 60 hertz. So I'm going to change the scaling again. There we go. 135 hertz. I'm going to keep backing it off counterclockwise. And I'm at the max now. 60 hertz with 2.5 volts peak to peak. Not too bad. There is a toggle switch here, FRL and FRH. So I'm going to try to toggle this and see what happens. And automatically we've lost our trace. We're at 714 hertz. Going to hit auto again. These scopes are very good. The auto function is very precise. I like it. Okay, so here we go. Still the 2.5 volts peak to peak, but now, 740 or so hertz. Yeah, there we go, 746. It's not 100% stable, but it's not too bad. And now, same thing, I'm going to crank the coarse adjust. There we go. So the coarse adjust gets us from 750-ish hertz to 570, 580-ish hertz. And then I'm going to crank it to the max and then turn the fine adjust. Hopefully you guys are not hearing the fan hum from the Rigol. It's not too bad, but could be picked up. So going up and up and up and up and up. We're in the 8 or 9 kilohertz range. I believe I'm maxed out. I'm gonna turn it a little bit more. There we go. Now I'm maxed out on that pot. And let's see if we can change the horizontal scaling. Whoops, wrong way. I do that all the time. So 9.26 kilohertz. That's not bad at all, actually. That's very reasonable, and we're still only drawing like 4 or 5 milliamps. That's pretty cool. Let's see if we can adjust now. We have a distortion control. I took a look at that real quick. Let me spin that. Okay, it's making the waveform look a little different. Look a little pointy at the bottom there. And the other way a little pointy at the top. And I'm guessing right in the middle. It's just about balanced. Looks like we're having a little bit of noise here. See the very peaks there? Okay, and we have another potentiometer here, the duty cycle. Oh yeah, I can change that wave into more of a sawtooth, sort of in both directions, more in one direction than the other. Okay, so let's see now what happens if we swap this to the square wave. The square wave is the interesting one, to me, at least. That's our square wave. We are maxing out our peak-to-peak voltage here. Let me just change the scaling. There we go. And can we center that? Nope. Okay, center that. I'm going to drop it down actually. Oh wow, need to change scaling some more. What am I changing here? Whoops, I'm going the fine adjust. There we go. So that is 2 volts per division, and we are 11.4 volts peak to peak. So we're only dropping a little bit of voltage through the chip here, and we are still at the 9.26-ish kilohertz. And you know what? That looks like a very nice square wave, actually. It's a little bit, the corners are a little bit rounded, but it's not too bad. It's better than I expected. That's a really nice kit. So let's see if we can distort the waveform. Not really. I don't think the distortion works on the square wave. Let's see if we can change the duty cycle. Oh, yes we can. Look at that. That's very nice. And again, we have our course adjust. So if I change the time base, there we go. Change it from 750 hertz up to 800, almost 900 kilohertz. Oh, no, sorry, 9 kilohertz. Yeah, it's a very nice kit, and I can swap it back to low. Play with the square wave, get the auto function going. Okay, and there we go. Now we're at 750 hertz, and we should be able to bring it down. 60 hertz. Looks like 60 hertz is the bottom end here. And again, we should be able to adjust the duty cycle. Yep. This is a very nice kit, actually. So the price, I only paid a few dollars for this, like literally a few dollars. So I think this kit is actually really, really nice. I think it's worth the money. Let's do the Sawtooth Wave. Yeah, I believe this thing is really worth the money. And let me know also if you like the new way of displaying the scope signal. It's a little bit more work for me, but I mean, who cares about me, really? I'm here for your entertainment. Let's change the volt. Oh, geez. Up. Let's move the signal down. There we go. Nice. That's a clean Sawtooth Wave, or triangle wave. It is bouncing around a little bit. It's on the low frequency. I'm going to move it up a bit. So there we go. Change this. Yeah, still bouncing around a bit, but 400 hertz. Very nice. Let's see if the distortion works for this guy. No, sine wave only on the distortion. But yeah, this is a nice little kit. So let me know what you think of this kit down in the description below. And for the rest of you, well, I would say get it. It's a nice little kit, fun to build. You don't have to get it from Alice. If you just look up whatever this is, ICL 8038, it's actually a discontinued chip, so very likely it is counterfeit, but that's fine. It's only a few bucks, very quick to solder up together, and really useful kit. The only thing I don't really know is what that diode does. No idea. But yeah, once again, thanks for watching.